Let's go to page 754. This is lesson 15-10. The objective of this lesson is to identify mutually exclusive and independent events and find the probability of such event. So over here, you have the set. So W is a universal set. So over here, you have the set A, and you have the set B. So A, you have 1, 2, 3, 4. B have 3, 4, 5, 6. Okay. So over here again, A is equal to 1, 2, 3, 4, and B equal to 3, 4, 5, 6. So notice that little bit over that. Okay. So if you're looking for the one that's in both, it's called the A intersect B. So upside down U, this is intersection. That means it's in A and also in B. So this will equal to the part that's in both A and B would be 3 and 4. Okay. So this is called the intersection. Now the union means you combine everything that's in A plus everything is in B. So in this case, this will equal to 1, 2, 3, 4, 5, 6. Okay. So again, intersection is in both A and in B only. Okay. So intersection is the part that intersect. So it's 3 and 4. Union means everything. So everything is in A or is in B. Okay. So you have to think of this is in A and also in B. Okay. This one means it's in A or in B. So think of this is and think of this is or. Okay, so this has to be in A and also in B, and so the answer would be 3 and 4. This is or means it can be in A or in B. So you got all these. Okay. Okay, now let's go to example 1. Okay, so here's your A. So you got 3 and 5, 1, 9, 7. This is C, so it's 6, 8, and 10. And B, you got 2, 4 over here. And D is 0, negative 1, negative 2. Okay. So over here, A, you're looking for A intersect B. So A intersect B is what is in A and how to be in B. So here's your A, here's your B, so it would be this right over here. Okay? So this will equal to 7 and 9. Okay. Okay. So again, you probably want to use a pen to write down your set, and then you can use the pencil to mark your the elements you're looking for. Okay. So for B, you're looking for A union B. So A union B would be this right over here. Say all right is in A or in B. Okay, so it would be that whole thing. Okay. So this will equal to 1, 3, 5, 9, 7, 10. So 1, 3, 5, 9, 7, 10, and 2 and 4. Okay. Okay, let's go to C. You're looking for B intersect C. Okay. So B intersect C is in B and also in C, so it'd be this right over here. Okay. So this would be equal to 9 and 10. Okay. Okay. So let's go to D. We got B union C. So B union C would be this right over here. Okay? So you're going to have 1, 9, 7. The order does not matter. Okay? 1, 9, 7, and you're going to get 6, 8, 10, and then you got 2 and 4. Okay? So that's B union C. Okay. Okay. Okay, now you go to E. You got A intersect D. So it has to be in A and a D at the same time. In this case, it's an empty set. Okay, so there's nothing. Empty set. Okay, let's go to F. You're looking for A union B intersect C. Okay, so this is a little bit tricky. So A union B is this whole thing right over here. Okay, this whole thing over here. Okay, now you have to intersect C. That means this also has to be part of the C. So this is out because this is not in C, right? Okay, this is out, this is not in C. This is out, this is not in C. Okay, okay. So again, A union B is this whole thing right over here. Okay, is this whole thing. Okay, this whole thing. Okay, that is this parentheses right over here. Okay, that's A union B right over here. Okay, then you have to intersect C. That means you have to be in C. Okay, that means and. So this has to be also in C. So this is not in C, so that's out. Right? This is not in C, so this is out. This is not in C, so this is out. Okay? So in this case, you're going to have 1, 9, and 10. So this is equal to 1, 9, and 10. Okay, and that's it. Okay? Okay. Now, if you look right in the middle of page 755, is the probability of the sample space equal to 1. So probability of everything is equal to 1. Okay? And probability of empty set equal to 0. Okay, so again, probability of sample space means probability of everything together is equal to 1. And probability of never happen will equal to 0. Okay. Okay. Now, also below that, you have this over here. So S is your sample space, means everything. Okay, you have the A and you have the B. And you got 1, 2, 3, 5, 4, and 6. Okay. So over here, you can see that probability of A is equal to 2 out of 6 numbers. And so probability of A equal to 2 out of 6. Okay. Probability of B equal to 1, 2, 3. So it'd be 3 out of 6. Okay. And probability of A union B, so A union B is, there are 4 numbers, 1, 2, 3, 4, so it'd be 4 out of 6. Okay. So if you know that A union B, this whole thing will equal to probability of A plus probability of B, right? So union, see, the everything would be A plus B, but notice this got counted twice. This one counted when you doing the probability A and also counted twice. You have to minus that. Okay. So what it's saying is that the probability of this whole thing is equal to probability of A plus probability of B, but this got counted twice, so you have to minus the overlap, the intersection. Okay? Again, use your common sense. This whole thing is equal to A plus the B, but minus the part over here because this got counted twice. Okay, then that's what that is. Okay. Now, if there's no overlap, okay, so mutually exclusive means you only can be either A or B. So you have this kind of situation. So if there's no overlap, then probability of A and union B, the whole thing would be just probability of A plus probability of B. Okay? Again, probability of this whole thing would be just probability of A plus probability of B, because there is no overlap. So you don't have to worry about this part. Okay? Okay, because nothing got counted twice. Okay, because there's no overlap, so nothing got counted twice, like this over here. So you don't have to minus that. So that's what it's saying. So this is called a mutually exclusive. Means it can be either A or B, but not both. Unlike this over here, see, this can be in A or B at both, right? So again, when you're doing this, right, use a picture, use a little bit of common sense. Again, this whole thing will be equal to A plus the probability of B, but this got counted twice, so you have to minus that. See, that's what this is, okay? But if there's no overlap, then if there's no overlap, this would be equal to 0, right? So when this is equal to 0, you get that, right? That's where it came from. So again, this is the overlap. So when there's no overlap, you just add them together, like this over here. Okay. And also, if there's no overlap, then probability of A, then probability of A and B happen would be just probability of A times probability of B. Okay. If they don't overlap, then you can just multiply like that. Okay, let's go to example 3. Okay, a bag contains 4 green. So 4 green, 4 blue. Okay, now you're going to draw 2 buttons shown at random. Okay, so for A, the first button drawn is put it back, so you're doing one at a time. Okay, and put it back in the bag before second one is shown. Okay, so this one you're going to get 1, you're going to put it back. Okay, okay. So A is green. Okay, A is the first, is equal to green, and B is the second button is blue. So first equal to green, and B, the second equal to blue. Okay? Okay, so probability A. So you're looking for probability of A. Okay, so first one is green. So to get green, there are 4 greens, right? So there are 4. That's even. That's what you want over sample space equal to 1/2. Okay. And probability of B. Okay, probability second one is blue. Okay, since you got put it back, so part A, everything got put back, so it doesn't affect anything, right? So when you put it back, the sample space is still the same. Okay, so the second button is blue. There are 4 blues out of A, so equal to 1/2. Okay. Now A intersect B. Okay. So when you put it back, right? So it does not affect any. So right now, you want so A intersect B means you want the first to be green and second one to be blue. Okay. So first one to be green. Okay, you can just, in the book, since you're getting one at a time, you can just use fraction. Okay, in the book they use combination. You don't have to. Okay, because combination is when you get more than one at a time. So when you're getting one at a time, it's easier to just use fraction. So you want to get the first one green, so it's 1/2. Since you put it back, the sample space is the same, so you get 8, right? And means multiply, and second one is blue, so you can. Okay, let's go and do this. So it's 4 out of 8, 4 out of 8. And so you multiply, you get 1/4. Okay. Now probability of A, so that's it. Okay. Now when you go to B, now B does not put back. Okay. So B is not putting back, so sample space changed. Okay, so now so P of A equal to 1/2 again. So when you get 1, right, you get it. That's it, right? So it's 1/2. Now probability of B is get complicated because it does not put back. Okay, so you want to get second one to be blue, right? So that means you have to use probability of first one is green, then blue, plus probability of first one is blue, and then blue. Okay. Now remember, this one does not get put back, right? So it's really complicated when you don't put back. Okay. So probability of first one is green is 4 out of 8. Okay. Now remember, this one you don't put back. So part B you don't put back. So you get green, you put aside. So now the sample space becomes 7. Okay. So now because the first one is green and get put aside, don't put it back. So now there's only 7 in the bag. Okay. And you want to get 4. There are 4 blues. So that would be 4 out of 7. Okay. Now over here, the first one is blue. Okay. So that's 4 out of 8. Now remember, you get 1, you put aside. So your sample space becomes 7, okay? But because the first one is blue, you put aside. Now there are only 3 blues in the bag. So when you don't put things back, you have to keep track of your sample space and your event, okay? So it gets complicated. So probability of getting a blue is equal to, you add this together, you get 28 out of 56 equal to 1/2. So you can see they are different now, okay? The probability of and then over here they do the A and B, okay? So that means the first is green and then blue, right? So to get the first one green, that's 4 out of 8, okay? And we already did over here, right? That's this one here, okay? And so this will equal to 2 out of 7, okay? So what I try to do is try to show you that when you have P of A times P of B equal to 1/4, and it's not equal to P of A intersect B. See that? So this times this does not equal to that. So that means this is that the A and B are dependent. Means it depends. The second one depends on what you draw on the first one. So when you don't put things back, then your probability of second one will be affected by the first one. Whereas when you put back, then it doesn't matter. Okay. So again, so mutually exclusive is easier, but when you are dependent, it's much complicated. Okay. Okay. Another thing we need to learn is the complement. So that's it. So probability of the sample space equal to 1, that's everything, right? So let's say if probability of getting an A equal to 1/3. That means probability of not getting an A, the bar means complement is not. So this will equal to 2/3, okay? Yeah, again, probability of getting an A is 1/3. Then that means not getting an A would be, the complement would be 2/3 because the whole thing has to equal to 1. So that's what it's saying. So this is very useful, okay? And so let's go to example 4 using this. It says based on the past performance in a school band, the probability that Ryan was selected. Okay, so Ryan gets selected is 3/4. Means Ryan does not get selected means equal to 1/4, right? Get selected is 3/4. That means not getting selected is 1/4. Okay, Faye will be selected is 2/3. That means not getting selected is 1/3. Okay, and Chan gets selected is 1/2. So not selected is 1/2. Okay, so again, first you have to get all the complement ready. Okay, so now for part A, you want looking for probability of Ryan and Chan are selected. So Ryan and Chan are selected, but Faye is not. Okay? Okay, so Ryan, Chan gets selected, Faye is not. So you just do that. So you got 3/4 times 1/2 times Faye is not is 1/3. So this is equal to 1/8. Okay? Okay, for part B, at least one of the 3 is selected. So at least one, what you do is you're going to get too many because you're going to get either this, or this, and you're going to get 2 of them, this 2, or this 2, and you get all 3. So it's too complicated. There are 7 cases. So whenever you have at least one, what you want to do, you want to do the complement. Okay? So this is equal to 1. That's everything. Probability of 1 is everything. Minus the probability of none gets selected. Okay? Okay, and this 1, So you want to do the opposite. You want to do none got selected, and you minus that. Okay? So this is equal to 1 minus, none gets selected, it would be 1/4 times 1/3 times 1/2. And so this is equal to 1 minus 1/24. And so this is equal to 23/24. Okay? So again, when you have at least 1, you have to, it's easier if you do the complement, to do the opposite. And you take away the opposite, and you get what you want. Okay?